That's your instructor for audio technology. I wanted to go over one of the demonstrations I did on our first day of class, and it has to do with phase. Phase, in this case, is the alignment in amplitude of different frequencies or different sound sources. This is important in live sound, in microphone placement, speaker placement, reflections in the room, and in your recording. I especially notice it when I'm using multiple mics, for example, recording a guitar in stereo. And this really becomes a factor when the microphones are different distances from the sound source. What happens is the arrival time of the sound just varies slightly in milliseconds, thousandths of a second, and the alignment of the waves and the recording can really make a difference in the sound, and it's something we need to pay attention to and listen for. To demonstrate this, I've dragged in a sine wave from a test CD. I'll play this here. Oops, let me get on the right screen. So that's 80 cycles per second. To zoom in this, we can see it graphically in Digital Performer here. I'm going to hit my zoom button. I didn't mean to go quite that much. So this we can also demonstrate what a cycle is. Actually, I will zoom in. Starting anywhere, like here's where the wave goes down, then it goes up and down again. So this would be one cycle from where it is in the curve to the next point where it's at the same place. The reason these are doubled up, by the way, is I got this from a CD, a test CD, and it's stereo, as CDs are. But they're doubled up for that reason. So you can see if you wanted to actually count these at 80 cycles per second, let me rewind. In our timeline, this is 2, 4, 6, 8 tenths, so this would be 1 second's worth. If you wanted to take the time to count these, you'd find 80 of these cycles in 1 second. Now, for more fun, we're going to double that. I'm going to use my duplicate tracks command, and it's going to give me another one that's absolutely identical. They're both play enabled here, so it should sound twice as loud, actually. So to show you I'm going to slip the phase here by dragging it in time. I'm really zoomed in here, as you can see. This would be an 80th of a second, right? So oops, it plays when I drag it. You know what, I'm going to make it a different color so it's easier to see, and I can do that here in my tracks overview window. Let's go back now. Rewind. So if I drag this, it becomes almost opposite, right? Let's see what it sounds like here. Make sure I play enable it. I don't want that there. It's getting quieter. In Digital Performer, we have a nudge command. If I hit the right arrow key, watch the blue waveform moving to the right slightly. So I'm going to do this while it's playing. Oh, it's really quiet now. And it totally disappears. At this point, you can see when this cycle is going down, this is going up. So this is demonstrates the effect of how sound can cancel other sound out. This is 100% canceling. By the way, this is the way your noise canceling headphones work, I believe. It samples the sound on the outside and creates a mirror image of it out of phase to cancel it apparently to your ears. So I'll keep nudging it here after I rewind. And you can hear it. Good. I'm going to shut down just one of these now. And I have another frequency here that I dragged in. This one is 63 cycles per second. We don't need these tracks. I'm just going to delete them. I was setting up my demonstration to make sure it would work. So in Digital Performer, when the blue triangle is on, the track is play enabled. Make sure I'm setting my output. I'm going through a USB mixing board here for the sound. Rewinding. This is in our tracks overview. I'm going to add in the 63. And we hear the pulsing, right? So what's causing that, let me hide the top one because I'm not using it. I'm going to make the 63 one visible. You can see how much longer these waveforms are. Let me drag that down. So what's happening here is that the phase is varying over time. So like at this point in the cycle, they're almost completely canceling each other out. Whereas at this point, they're reinforcing each other. So when the phase like this varies over time, you'll hear this pulsing effect in volume. So at this point, it would be loud. At this point, it'd be quiet. And as this goes by quickly, we're hearing these, I don't know what to pulses. So this is the phase being affected. I hope you found this interesting, and keep this in mind when we apply it to actual recording and microphones.